All right. 5, 6, missing one person still. Let's see. Who am I waiting
Gavin.
for?
Oh, wait, no, he's here.
Now I have Gavin. All right. I'm going to go around the room where we were sitting. Matthew. Oh, Karen?
Oh, yeah.
Okay. Did you guys see Karen in your other classes this morning?
Yeah.
All right. They just needed a quick break to go to the bathroom or something.
Yeah.
Okay. Well, we'll start then. Page 545. We started with number 54.
Karen's here.
Hi, Karen. 54D, because we had done A, B, and C. Okay. So when we did A, we said, is the polynomial a difference of two squares? No. Which expression shows how to factor out the GCF? That was B. Which, if any pattern could be used to factor the resulting expression, the difference of two perfect squares. And then they wanted us to factor that. Okay. So what did you get, Lauren, for this is 54 part D?
I got 2x squared times the quantity of y squared minus 4 times the quantity of y squared plus 4.
All right. 2x squared times the quantity y squared minus 4 times the quantity y squared plus 4.
Can we keep going with that?
Is that what you said?
Yeah.
Yes. Go one more time.
Yeah, so that then we would take the y squared minus 4 and then
and make it
y minus 2y plus 2.
Okay. So then your final is 2x squared, y squared plus 4, y minus 2, y plus 2. Can you guys see that? Okay. So it's an example of how we have to keep on factoring, okay? We keep going all the way until we're done. All right, good work for that one, Lauren.
Thank you.
Number 55 says Carly is factoring the expression 6x to the 5th minus 54x. Which of the following statements is true? A, x squared minus 3 is not a difference of squares. B, x to the 4th minus 9 is not a difference of squares. C, the complete factored form of the expression is 6x times the quantity x to the 4th minus 9. D, the expression cannot be factored. So we're starting out with 6x to the 5th minus 54x. Matthew, what did you circle for this one? A, B, C, or D? Is Matthew not there? Oh, Matthew. Okay. Nathan, what did you fill in? Which circle?
B.
B. X squared minus 9 is not a difference of squares. That one is a difference of squares. It's a difference because we're subtracting, and x to the 4th is a square and 9 is a square. So that one, we're trying to do the one. Oh, wait.
Oh, you have 55. Oh my gosh, I'm so sorry.
Yeah.
Oh, I said
which of the following statements is true? Yeah. So that says it's not a difference, but it is a difference.
Yeah, I said C. Sorry. I thought you meant.
Which one did you say?
C. I thought you meant 54.
All right. C, the complete factored form. Let me see the complete factored form. I'm going to factor out a 6x, and I'll be left with x to the 4th minus 9. Oh, and that says that's the complete factored form. But I can factor that further, Nathan. I can factor x to the 4th minus 9 further. Okay? So C is not true, and D is not true because the expression cannot be factored. You already started factoring it. So it has to be A, x squared minus 3 is not a difference of squares. All right. Yeah, that is true because 3 is not a square. All right. So 55, you should have circled A. All right. Because the complete factored form is there. All right. So 55 is A. 56 was a skip, right? 56 we didn't do. So we skipped over to 57. The area of a square is represented by 16x squared plus 40x plus 25. Find the length of each side. So you have to factor it. And Abby, what did you get for that?
For 57?
Yes.
Oh, wait. I guess I didn't do that one.
Okay. Gavin, what did you get for that one? Gavin, I can't tell if you're with me because all I see is something that sort of looks like a giant-eyed pyramid. So I can't see you. You're still muted, so you might be talking to me. I'm not sure.
For the past 2 classes, he left to, like, we couldn't talk to him. Like, for Spanish class, like, we couldn't see him.
Oh.
I don't know where he is.
Okay. So I guess I'm going to take that, Gavin, unless you email me and tell me something differently, like there's something up with your computer and you can neither be seen or speak, that you're really not here, that you logged in and you're someplace else, I guess.
Mm-hmm.
I got it. Do you want me to say?
All right. Back to you, Abby.
I said the quantity of 4x plus 5 times the quantity of 4x plus 5.
Okay. So answer the question now. That's factored.
Oh.
The question said, what is the length of each side? So if it's a square, right, and the area is length times width, but now I want you to answer the question. What's one side?
Is it 4x plus 5 squared?
It's just 4x plus 5. It's just one of those, right? If that whole thing is the area, that's your length times width. So that's like your length and your width. It's a square, so it makes sense that they're the same. So one side is one of those, your length or your width.
All my dogs are not nice.
Why does that, Nathan?
Nothing.
All right. Number 58. The area of a circle is area equals pi times the quantity 25x squared minus 40x plus 16, which represents the radius of a circle. Area of a circle is pi r squared. So they're saying that the 25x squared minus 40x plus 16 part is your r squared. And then if you took the square root of that. All right. So Nicholas, word to you for number 58. And tell me what you filled in. A, B, C, or D, Nicholas?
D, I said.
D. Okay. So when you factored that, you got 5x minus 4, 5x minus 4, right? So that is D. Okay. That's fine for the factored part. They're asking what the radius is. So think about it. I just want you to put this in your head. You did good factoring it. That's fine. Area of a circle is pi r squared. So they're saying that whole thing is r squared. So when you got 5x minus 4 squared, okay, that's your r squared. So your r is just 5x minus 4. Okay, so you did a good job factoring. To answer the question, it would be C. The radius is 5x minus 4. And they're asking about the radius. But as long as you could factor it correctly, I'm happy. All right, 59.
What was 55 and 57?
Where were you at, Matthew? Oh, yeah, where were you, Matthew?
Restroom.
Okay, this is recording, so go back and look at those later, okay? Don't make us take time to go back now.
Okay.
All right?
Okay.
All right, but we are, if you want to catch up to where we're at, we're on 59, Matthew. Okay? 59 was so much fun, and I'm on Nicholas just did that one. I'm on, who's under Nicholas? Emma, 59. What did you get?
I got B.
That is correct. This was my favorite problem ever, guys. Look, the difference between two perfect squares. So it becomes x to the 8th plus y to the 8th and x to the 8th minus y to the 8th. And then I was like, that's still the difference between two perfect squares. All right. So then we have x to the 8th, y to the 8th, x to the 4th plus y to the 4th times x to the 4th minus y to the 4th. We still have the difference between two perfect squares. Keep going. Now we have x to the 8th plus y to the 8th, x to the 4th plus y to the 4th, x squared plus y squared, x squared minus y squared. What? We still have the difference between two perfect squares. I was so excited. X to the 8th plus y to the 8th, x to the 4th plus y to the 4th, x to the 2nd plus y to the 2nd, x plus y, x minus y, and that's where we have to stop. Okay? So B is correct, Emma.
Finally.
Right? That was a lot of steps. That was the most fun problem ever. Okay. Number 60 said, determine whether the following statement is true or false. Give an example or a counterexample. And the statement said, for a trinomial to be a perfect square trinomial, the middle term must be positive. The middle term must be positive. Karen, did you say true or false for number 60?
I don't know because I think I forgot to do it accidentally.
Okay, that's okay. Lauren, what did you say for 60? True or false?
I said false.
False is correct. What did you use for a counterexample?
I said that all of them need to be perfect squares.
Well, the middle term does not need to be a perfect square.
Yeah.
So, like, we might have, and I'm just try to look for an example of one in the book. A perfect square trinomial. Here they go. They are on page 540. So you could have given me this one. 9x squared minus 6x plus 4. This is a perfect square trinomial. That one does have to be a perfect square, Lauren. That has to be a perfect square. But look, this doesn't have to be a perfect square, and it could be negative. It doesn't have to be positive. This is 3x minus 2, 3x minus 2. So if our middle term is negative and our last term is positive, that's okay. Okay, because or for our outers and our inners, we get that negative. And then for our last term, a negative times a negative is a positive. So that one was false. And that's a counterexample for it. All right. The middle term could be negative and you still have a perfect square trinomial. All right. Number 61. The volume of a swimming pool is represented. They give us this big expression. Find the possible dimensions of the pool if dimensions are represented by polynomials with integer coefficients. Basically, they were like, factor that problem. Okay. And I'm on Matthew. So Matthew, what did you get for 61?
I didn't get that.
Okay. Is it because it was like confusing with that whole story problem?
Yeah.
Matthew?
Yeah.
What if it would have said factor this problem? Would you have been okay?
Yeah. I forgot you said to do that.
What is the first thing you would do? I'm not asking you to do it now, but in your head, if it just said factor that, what's the first thing you look for? You would have looked at those numbers. And said, all right. Even before that, you would have said, is there anything I can
take out?
Yeah, anything I could factor out. All right, let me go to Nathan. Nathan, did you factor that one? You're muted, Nathan. I can see your lips moving, but I can't hear you.
I didn't get this one either, but I can try it, I guess.
All right, Abby, what did you get for 61?
I don't think I got it right, but I have 3 times the quantity of 4x to the third minus 28x squared plus 49.
You could have factored that a little bit more. You could have taken out another x. Gavin, are you back with us by any chance? Gavin?
Yeah.
Wait, is that you?
Yep.
Where have you been?
Sorry, I went to the bathroom.
Okay. Gavin, we're on 61.
Do you want me to give you the final thing?
Yeah.
3 and then in parentheses 4x to the 6th power plus 44.
No, that's not quite it. Let me go to Nick. What you got, Nick?
For number
61.
61, I got 3x times the quantity 2x minus 7 times the quantity 2x minus 7.
That's it. All right. So basically, they give us that big story about the swimming pool, and the directions are just factor this. Okay. Matthew said the first thing he would think if he would have done this problem was, what can I factor out? So you could factor out a 3x, and you're left with 4x squared minus 28x plus 49. And then you don't want to stop there because you can factor it further, like Nicholas said. So those are the dimensions of the pool: 3x, 2x minus 7, and 2x minus 7, right? That's your length, your width, and your depth. Right. There was only one more problem, number 62. It says, which expression is equivalent? This is one that you had to factor, and you had to factor by grouping because we have 4 terms. All right. So we have to maybe rearrange them and put them in order next to something that we'll be able to factor something out. So this one had a lot of work to it. And what letter did you get for your final answer, Emma?
C.
Correct. Show you guys the steps to that one. Okay, you start out with 3r to the third, and we're going to move minus 3r next to it. So first step, we're just going to change the order. All right, so then we could factor 3r away from the first 2, and we have r squared minus 1 left. And now we could factor minus 7 out of the second 2 terms, and we're left with r squared minus 1. Okay, and then we notice, oh yeah, they both have an r squared minus 1. So we could factor that out. It leaves us with 3r minus 7 times r squared minus 1. But you don't want to stop there because this is the difference between 2 perfect squares. 3r minus 7 times r plus 1r minus 1. C. Okay, so those are as complicated as they get for us. Those ones were tricky ones. I don't know if you had seen, I had put on Parent Square like a while back. If you wanted to do those ones for extra credit, you could do them and then show them to me. And I did that because those ones were more difficult, a lot of the tricky ones. All right. Do you guys have questions on any of those?
No.
Okay. So give me 1 second. Okay. There's something else that I want us to be able to cover. This finished up our chapter 8. And then this finishes up algebra 1. All right, that's the last section. That's the hardest part. Chapter 9 is quadratic.
Yay.
Yay! You guys did it, and it's only like May 5th. Chapter 9 is quadratic functions and equations. That's algebra 2.
Yikes.
The other part of algebra 1 that we need to talk about is things like mean, median, mode, some probability, okay? So we're getting out of like variables and factoring and exponents and all of that. And I want to review. I know we
I
did.
don't like these.
I know we did mean, median, and mode last year because we did it. I'm doing it this year with my 6th graders. So I know you and I did it last year, but I want us to go back over that. So I want you to flip to page 672. Page 672. It's like, okay, chapter 9 is algebra 2. Chapter 10 does some mode, median, and mean. And this is like where the mid-chapter quiz would be. Number 1 says, find the mean, median, and mode for each set of data. Okay, number 1, let's just start with the mean. The mean. Remember, Mrs. Palmer always said the mean is so mean because it makes us do all this work. How do I find the mean? Raise your hand if you want to answer that. Nathan?
So don't you add up all of the numbers and then divide them by how many numbers there are?
Exactly. Good remembering. Good. Lauren?
I got it.
Oh, number 1? Hey,
Yeah.
you guys are so fast. Okay, so Nathan was correct. You have to add up 10 plus 11 plus 18 plus 24 plus 30. If you have a calculator, this can be done by hand, but I do know you guys know how to add. So I'm okay if you use a calculator. You can use a calculator taking all your standardized tests. So you're going to add those up. So take out your calculator and add them up. Divide by however many numbers there are there. What did you get, Lauren?
69.
When you added them all up or for your final answer?
For my final answer.
Did you say 69?
Yes.
Are you on page 672, number 1?
I think I am.
Okay, because if you say 69, like the mean is the average. And when I'm looking at those numbers, 10, 11, 18, 24, and 30, like 69 couldn't be the average of that because that's like way higher than any of them. Maybe you just typed something in wrong when you were adding. Emma, what did you get?
I got 18.6.
Yeah, that's what it's 18.6. So try it again, Lauren. Just add 10 plus 11 plus 18 plus 4 plus 30. You get 94. And then divide by 5 because there were 5 numbers.
Yeah.
And I also got the next one, if you want.
All right. Oh, hang on. So if you ever do get an answer like that, though, and or you're on a multiple choice and 69 is one of your choices, like you'd be able to cross that off right away because like there's no way that could be. The next thing we have to find is the median. The median means if you put them in order from smallest to biggest, and they're already in that order, we have to find the number. What is the median? Abby?
Isn't it the number in the middle?
Yes, the number in the middle. So if we have 5 numbers, there will be one number in the middle. If we have an odd number of data, we find the one number in the middle. Abby, what's the number in the middle there?
18.
Good. All right, so our median is 18, the number in the middle. If you have an even number of data, you have to find the 2 numbers in the middle and then find the average of them, add them together and divide by 2. But this time there was one number, 18, and we have to find the mode. Nathan?
Is the mode 30?
No, the mode isn't 30. What does mode mean? The mode, the number we see, Emma?
The most.
The most. Okay. Which number do you see the most there, Matthew?
No.
They're all the same.
They're all the same. So what's my mode?
Nothing.
No mode. Yep. Don't say 0 because sometimes 0 is a mode, like that's a value. So you're going to say no mode. All right. If all the numbers appear exactly the same number of times, the answer is no mode.
Can I say everything for the next one?
You already did the next one?
Yeah.
Okay. What's the mean, Matthew?
10,
Median.
9,
Mode.
9.
Yes. 10, 9, 9. Good. So mean, median, and mode.
Number 3.
Okay, number 3. I want you to do number 3 for homework. Find the mean, median, and mode. I think that is just I'll just have you guys do that one for tonight. And then tomorrow we're going to talk about the, like box and whisker plots where we have to find the upper quartile and the lower quartile.
Oh, I hate them.
Okay,
Just
but
a big
I want
pain.
you guys to do page 672, number 3. Okay. You guys have any questions?
Nope.
All right. Mean, median, and mode. Okay, and boys and girls, it says of each data set. So Sunnydale and Sun Valley are 2 different data sets. So you're going to kind of be doing it twice. It's really like 2 problems. You have to do one for Sunnydale and then one for Sun Valley. Okay?
Okay.
All right. All right. I'll see you tomorrow. Have a good day.
Bye.
Bye-bye.
Bye.
Bye.